if you can go to the first slide that I prepared for Malin 1, you'll see a part of the area that we're sitting at now. Basically, over the last several months, we have been descending down into a depression off of the plateau on which Curiosity landed, and we've now reached the bottom of that depression. We're looking back towards the direction we came from at the stratigraphy, at the layering in the rock that we've descended into. In the first image that you see here, you see the two lowermost units. The lower one we're calling sheep bed, and the second one, which is the surface just above the little cliff that you see there. That cliff is only like the size of the margin of a sidewalk. The upper one is called Gillespie, and what we are starting to see are lots of attributes of these lower units, some of which are representative of how the materials were emplaced, and some of the features are telling us what has happened to them after they were emplaced. The area that we're very excited about, or things we're very excited about, are pointed off in the enlargement on the right, where you can see with white arrows small linear features which are cracks that have been filled with a mineral by a mineral, and those are veins of material that have been injected into this rock. And the dark arrows, the black arrows, are pointing to concretions, which are similar to those seen at the Opportunity landing site from Mur. The next slide shows the John Klein area, the area just above the scale bar is the John Klein area. It's a region that has lots of these veins and concretions. I'll come to that at a higher resolution in a moment, but I wanted to point out the high diversity of rock types in this area. The small boxes indicate A, B, and C are enlargements on the right, show a number of different types of rocks that we see in this area. So diversity is always a measure of the number of processes and the different types of materials. And this is a very diverse area. One of the reasons we're going slowly is we want to make sure we characterize that diversity. The rock in the upper left there, at top right enlargement, is a bread-crusted rock. That rock has the interior has shrunken relative to the crust, or the outer part is expanded to form these fractures, and that's indicating something has caused that rock to go through that type of a change. I'll go to the last slide, which is actually the John Klein site. That is also an indication that shows an enlargements on the right and the top and middle of the veins that we are interested in, also the concretions, and as I said, those will be described shortly after I finish. The lower right is in the C location is a small hole or pit that has developed in the fracturing in this location. That's caused by sand infiltrating down into a crack and not being replenished from above. So it's likely this is a relatively recent feature, or sand would have refilled in that hole. But we've seen these holes in a variety of places, which suggest that the area is still undergoing some changes. The rocks are very diverse, and I'm going to hand it over to Aileen Yingst, who's going to talk a little bit about what we see with the MAHLI.
Well, good morning, everybody, and best wishes from very chilly Wisconsin. MAHLI has been having an absolute field day at this site. We've really acquired some fabulous images, including some nearly at MAHLI's best resolution of about 16 microns a pixel. These images demonstrate the diversity of rock texture here, something else that makes it an attractive site. So if you'll go to the slide Yingst 1, just to give you an idea of the real estate here, this is an image taken by MAHLI from about 5 centimeters offset distance. The image itself is about 3.5 centimeters across. And what you're seeing here is a relatively dust-free, coarse-grained sandstone, where sand has a very specific definition of grain sizes from 125 microns to about 2 millimeters. And the thing that's interesting about this image is that there are several larger grains in the matrix, and they are pointed out by the yellow arrows. Now, one of these, the lowest one, has caused somewhat of a stir in cyberspace. It's a little clearer with an unusual shape. This is also approximately a sand-sized grain, a lot larger. It's on the large end. But it's interesting because of that color and luster and shape, which tells us it might be composed of something a little different. But in general, this entire image shows a real diversity of the size of grains and the distribution of grains. Many of these larger grains are actually rounded. So if we move on to the slide Yingst 2, this is from the Equire 1 target. This is a GIF of before and after brushing, and MAHLI took these images from about a 25 or a 25 centimeter or 10-inch offset distance. And this spot is something like 2 by 2.5 inches, the brush spot. So if you move on to the slide Yingst 3, this is a close-up of the previous image that you saw, and the real estate covered here is a lot smaller. This is taken from 1 centimeter offset distance, which is absolutely astounding that we can get that close with a 7-foot arm that weighs 200 pounds. So this is just from a centimeter off the ground, and the entire area covered in the image is less than that of a small postage stamp. It's a very small piece of real estate. This is a very fine-grained rock. The grains are at or below MAHLI resolution. The black grains are approximately 2 to 3 pixels across, so 35 to 50 microns. But we're looking at silt grains here, and these grains might represent the particle size of all of them, or it could just be at the large end of the distribution. So the stuff we're looking at here is finer than powdered sugar, but coarser than the sugar that's typically used to make icing. So the site contains a broad variety of rock textures, anything from conglomerate to sandstone to siltstone, and all of these are sedimentary rocks, meaning that other rocks had to be broken down into fragments and transported elsewhere and then turned into rocks, lithified, meaning that Mars, at least in this location, was geologically active enough to have created such rocks, which is totally cool. And the different grain sizes in each of these and the distribution tell us that all 3 rocks were formed by different conditions. So it was active in a diverse sense with 1 or more transport mechanisms in play. All in all, very exciting for drilling.